and snapshots. AMIs is nothing but images of your EC2 instance. Okay, it completely takes an image of your EC2 instance, and you can use that image to spin up any number of EC2 instances similar to the one that you took image from. Right, so that's very useful. That's very useful when it comes to automation and when it comes to using those snapshots to copy your entire EC2 instance and keep a backup of it just in case your EC2 instance fails. You can easily bring it back from your AMI. Snapshots are again a point in time snapshot of your EBS volume. So we looked at an example where we took a snapshot of your EBS volume, and then we provisioned a new volume out of it and then attached it to another EC2 instance, and we were able to use the entire data that was there in the first EC2 instance. And also we looked at snapshot policies. You know how snapshot policies work, right? You create tags and then you set a policy for those tags, and then the policy will keep going and taking the snapshots of all the EC2 instances which has got EBS volumes which have that certain tag in it. So that's very useful while you want to automate your entire backup process. Then elastic network interface. Elastic network interface are the actual NIC cards associated with your EC2 instances. You can provision more than one elastic network interface, right? And when you want when you want a public facing EC2 instance in public subnet, right, you actually associate an elastic IP to the elastic network interface. So your elastic network interface will have one side public facing elastic IP, the other side private facing internal IP. Then we looked at how to provision Windows EC2 instances and how to pass EC2 user data to your EC2 instance, right? I mean, we looked at automating the entire process of setting up a web server on an EC2 instance through EC2 user data, where we wrote a small shell script. That shell script would actually get executed when the EC2 instance comes up for the first time. And the shell script would actually go ahead and install HTTPD, which is Apache web server. And then it would actually create a new HTML file called hello RPL champs, right? And then instance metadata. Instance metadata is a endpoint which you can invoke from your EC2 instances, which will actually give you have to create a token and then use that token to query the metadata about your EC2 instance. It's an HTTP endpoint. Okay, then we looked at IAM, right? IAM is a very important topic. I've been stressing that. I've been emphasizing that a lot, right? I can't emphasize more. IAM is a very important topic. IAM is identity and access management. It is one of the fundamental pillars of AWS platform. Without IAM, AWS platform wouldn't exist. So IAM is basically the pillar that ensures that authentication authorization is managed with the entire AWS platform for all the AWS resources and also the resources that customers that you create. Okay, and you all need to understand, you know, how IAM works, what are IAM users, how to create a password, how to create a access key and secret key for API and SDK calls. So any user who logs in into the console makes a bunch of API calls. All the API calls within AWS platform would need an authentication token. So either that authentication token can come from the login credentials that you have logged in as a user, right, using your IAM user password or root user password, or it can be coming from your access key and secret key. At the end of the day, every call that goes goes as an API, and every API call would need an authentication token to be available, right? And also we looked at how to secure your root user credentials using MFA, not just root user, also your IAM user credentials using multi-factor authentication using one of the authenticator services. In this case, we took a Google Authenticator. So then we looked at policies, right? How to frame policies, right? How the policies work, right? And how you know, how the policies would work in the context of, say, allow and deny, right? Which would take the preference. I showed you all a flow chart. I gave a pointer to that flow chart in the assignment document. So all of you should understand that flow chart very clearly, that every IAM operation starts with deny. Then it looks at the explicit deny. If there is an explicit deny, it denies. Then it looks for an allow. If there is an allow, it If there is an allow, then it goes ahead and allows it. So it all starts with by default deny, right? By default explicit deny. Okay, there's one thing that which we are still pending is the EC2 IAM instance profile. We will cover that subsequently in one of our subsequent labs. That's also quite interesting. It's linked to roles, and we also looked at roles. Roles are nothing but a way to create a role and associate that role with an entity, which can assume that role and which can basically use that role to execute functions on your behalf. Okay, that's called roles. Roles will need to be assumed. So now this week, what we're going to cover is we're going to cover S3. We'll start with S3 today, right? We'll start with an introduction to S3. Again, S3 is a very, very important topic, right? Definitely you will have questions asked during the interview on S3. And tomorrow we will cover more advanced topics on S3 because S3 also has got IAM style policies, which are called bucket policies. You'll have to explain, you'll have to understand that very clearly. So then we'll look at CloudFront, and then we will do a small lab around S3 and CloudFront, right? And then you can do databases on AWS, which is on 12th November and 13th November. We'll cover databases on AWS. Okay, so now let's get back. Okay, what is S3? So how many people are there? Around 60 odd people are there. Okay, all right. So what is S3? Right, S3 is basically as the name says, it's simple storage service, and it's a object storage. Okay, it's like your Dropbox. It's like your Google Drive, right? So where you can store anything. You can store any object in your Dropbox, right? I mean, it can be images, it can be documents, it can be files, it can be a zip file, it can be anything, right? It does not restrict on any of the extensions that you can store in the Dropbox, right? Similar to that, Amazon has got a internet scale simple storage service, which is called in simple terms S3 SSS, right? So triple S, simple storage service. So S3. Okay, and it's designed grounds up for the sake of internet. Okay, like how applications would working on the internet would need a storage mechanism to store their objects and store their files, and it is designed to make web scale programming computing easy for developers, right? I mean, in this case, if I have to basically deal with a lot of files and have to deal with a lot of objects, I mean, it basically makes it very, very easy for developers. You're going to see that. Okay, Amazon S3 has a simple web services interface that you can use to store and retrieve any amount of data at any time from anywhere on the web. It gives any developer access to the same highly scalable, reliable, fast, inexpensive data storage infrastructure that Amazon uses to run its own global network of websites. Okay, in fact, this something interesting that I want to basically share with all of you. Okay, so initially, if you see, Amazon as an organization, as a company started in 90s. Okay, so that's when Jeff Bezos, who founded Amazon, wanted to change the way commerce works in the world, right? E-commerce works in the world. So that's when he first started an e-commerce website. Okay, and he named it Amazon.com, and he wanted to sell books initially, right? And he wanted to just start selling books, right? And then he started selling books, and he started building his website, and within a few months his website was ready, right? And then he didn't have a place where he could maintain an inventory and things like that. So in his house, in his garage, he's put his entire infrastructure. Like he had a bookshelf, and then he had his computer systems, which are serving Amazon.com website. It was all based out of his garage. Okay, that's a very famous story that you can find it over the internet also. It's there on YouTube. So he first set it up in his garage, and Jeff Bezos, along with a few of his associates, started this, right? And that's when he started programming the Amazon.com. Then he set it up, and then he waited for several weeks and several months for the first order to be placed in his system. Okay, so now when the first order got placed, I mean, they had programmed it in such a way that when there is a first order, there would be a bell that would ring in his garage. Okay, so now Jeff Bezos said that, I mean, he waited for several months for the bell to ring. Okay, which means, I mean, he didn't have any business. I mean, he was just running his website and he was just waiting for, the first order to be placed. Okay, so that was his persistence, right? So today, if you see Amazon, it has reached greater heights, right? I mean, unimaginable heights, correct? So that's the persistence and that's the perseverance that he had, right? And he set up his first bookshop, online bookshop, and then the first order came in, and then there's no looking back from them. And today, all of us know and are witnessing what is Amazon's growth story. Okay, and all of us are using Amazon's, web services, not just web services. All of us are using Amazon's e-commerce services, right? So now, if you observe this, it basically says one thing, right? So where it gives any developer access to the same highly scalable, reliable, fast, inexpensive data storage infrastructure that Amazon uses to run its own global network of websites. Right now, Amazon is a global organization. It has so many businesses, right? It has e-commerce, it has cloud, it has payment business, right? It has so many businesses, right? And in fact, Amazon is foraying into a lot of other businesses as well as we speak, right? So now, here in this case, it uses the same inexpensive data storage infrastructure that Amazon uses to run its own global network of websites. So that way, what Amazon did was, as part of their initial, before cloud came into existence, when they were actually into the e-commerce business, and when they were actually going full swing on their e-commerce business, probably in 2000s, that's when Amazon had built all of this EC2 and S3 internally for their own use, right? So where they had set up data centers, and they had set up a lot of automation around ensuring that their Amazon.com scales very well, because that's very important that Amazon.com scales well, right? And that's when Amazon started building all of these services internally as for their own internal use, like EC2, even S3, right, for that matter. Because being an e-commerce website, they would need to store a lot of images, right? Photos of products and so many things, reviews and so on and so forth, right? So that way, that's when they started building EC2 and S3 for their own internal use. But then when cloud started coming in, so that's when they actually spun it off as a separate business unit, and then they started providing these as cloud services. But otherwise, if you see, these are all built internally for Amazon's own internal use, right? And over a period of time, they made it as a separate service. That's why if you see, a lot of services are built by Amazon. Okay, and AWS was spun off from that. And if you see, a lot of services would still carry the name Amazon. Okay, Amazon S3. Okay, a lot of those services which are actually built by Amazon and are commoditized by AWS, right? I mean, so anyways, these are small tidbits that would make it interesting. But anyways, coming back, all of us know today, how many services AWS is offering today, right? I mean, it's a wide range of services, and there's no limit to the innovation is in AWS, right? And all of you must have heard of the news that was announced a couple of days back, that a new region in India is announced, and that's all coming in Hyderabad. Okay, that's made official now, right? And by mid 2022, there will be a brand new region in India, which is in Hyderabad. Okay, second region in India. So right now we have AP South 1, correct? AP-South-1. So you will have AP-South-2 as the second region in India. Okay, all right. So that's kind of an introduction to Amazon S3. Right now, let's go a little more deeper into what Amazon S3 is all about, right? Okay, so now the way Amazon S3 works is, Amazon S3 is a object storage. Okay, it is not a block storage, right? Last week, we all looked at block storage. What is block storage? Block storage is EBS, which stores blocks, right? I mean, it's like a block, which can be associated with an operating system. And the operating system reads and writes from that block storage, right? Because it's all stored as blocks of, whatever, 4 KB or 1024 KB or whatever it is, right? So that's where, if you see, it's a block storage where you you create a block, EBS block of 30 GB, 40 GB, 100 GB, and then you associate it with your EC2 instance, right? And then your EC2 instance, like how you have a hard disk, right? In hard disk, you go and create a partition, and then you use that partition to deploy your operating system, C drive, D drive, and so on and so forth, right? But unlike that, this is not a block storage. This is a object storage, because everything is an object for Amazon S3. An object can be anything. Okay, an object can be a file, a text file, an image file, a zip file, a binary file, your Java file, your jar file, Python file, anything. It can be anything, or it can even be just an object. I mean, no extension also. You just create one file, anything, random thing, no extension. You can also upload it into S3, right? At the end of the day, it's just an object, right? It's an object storage which stores and retrieves objects, from the S3, right? And that way, you can also granularly control the permissions for each and every object that you store. It's very similar to your Google Drive or Dropbox, or Microsoft has got OneDrive, correct? It's very similar to that. Okay, and what it does is, it basically interacts. Users can interact with Amazon S3 in 2 ways, or rather 3 ways, right? So the first way is called the command, the console, right? So where you have your EC2 console, your S3 console, and using your S3 console, you can interact with S3, where you can upload objects, download objects, you can view your objects, you can manage the permissions of the objects, you can manage the property of these objects. Okay, that is through console, through the management console, through the AWS management console. Second option is API. Okay, S3 has got APIs. You can invoke those APIs, and S3 only supports REST APIs. It does not support SOAP, right? I mean, how many of you know the difference between SOAP and REST? Can somebody explain what is the difference between a SOAP and REST? Okay, if you don't know, I'll give you some links. Please read through SOAP versus REST. Yeah, so you can just read through this. SOAP is called Simple Object Access Protocol. REST is Representational State Transfer. Okay, so now these are the 2 types of APIs that are there, but now SOAP has become old. Hardly the modern systems hardly use SOAP interface. Okay, most of the modern systems use only REST because of the limitations that SOAP has with respect to creating a proxy and creating a contract and things like that. But REST has nothing of that sort. You just invoke REST, and REST works on just HTTP, and you can just make use of REST out of the box. Okay, so now what Amazon S3 gives us, I mean, S3 gives only support to the latest versions of S3 gives only support to REST interface. It does not support SOAP. I mean, no longer. I mean, it used to support SOAP, the older version, but now the new version only supports REST, and it's also good to use REST interface. Okay, that is the second way of doing it. The third way of interacting with an S3 is using SDK, right? You can also use SDK like Boto. Okay, Boto SDK is there. You can use Boto SDK to like Python SDK. When I say Boto, Python, right? Python or a .NET or a Java, right? So some of these SDKs can be used to interact with S3 programmatically and retrieve and write objects to S3. Okay, what are the advantages of using Amazon S3? Amazon S3 is intentionally built with a minimal feature set that focuses on simplicity and robustness, right? I mean, it's just meant to perform the job. Okay, no frills attached, right? No jazzy features. it just gives you the right set of features to keep it lightweight and to ensure that you are able to focus on simplicity and robustness, and it is fast, right? The performance, and it has huge scalability, right? I mean, it is like you can't imagine, right? I mean, Amazon S3 is like infinite. You can store as much data as you want. There's no limit to it. It's not like you go to S3 and you can only store so much, right? So okay, so now what are those advantages? One is creating buckets, right? So now bucket is called bucket, right? I mean, normal bucket that we have, right? We use buckets to store things like water, any other objects and things like that, right? Like you have buckets and you can basically bucket your multiple different objects into a bucket, right? Normal in real life. So that's where if you see a bucket in Amazon S3 is basically a container which can store the objects. Okay, they are the fundamental containers. That's so you need to have a bucket to store objects into S3. Okay, storing data, store an infinite amount of data in a bucket, upload as many objects as you like into an Amazon S3 bucket. Each object can contain up to 5 TB of data. So that is the maximum size each object can have. But the number of objects itself is infinite. You can have any number of objects into a bucket. There's no limit to the number of objects that you can store within a bucket. But the maximum size that an object can have is 5 terabyte. 5 terabyte is a huge, okay, 5 terabyte is a huge size which you can store as a single object in a bucket. Yeah. Then you can also download your data or enable others to do. You can give permissions. Okay, and you can those objects can be available publicly. Anybody can download those objects, and it's there on the internet, correct? So, and permissions, grant or deny access to others who want to upload or download data into your Amazon S3 bucket. Grant, upload, and download permissions to 3 types of users. Authentication mechanisms can help data secure from unauthorized access, right? You can always prevent users from accessing your bucket. All those granular permissions can be made available. So we are going to look at all of that. Okay, now let's get into some of the concepts, right? So the first thing that you need to understand is bucket. As I said, bucket is a container for objects stored in Amazon S3, right? So now, like how we have buckets, where we use those buckets for multiple different types. Similarly, in S3, you have something called a bucket. You need to create a bucket. It's like a folder. I mean, I won't say exactly a folder because within buckets, you can create folders, but it's like a top level folder, right? Which can contain objects. Okay, every object is contained in a bucket. For example, if the object named photos/puppy.jpg stored in the AWS example bucket in the US West Oregon region, then it is addressable using the URL https:// the bucket name, which is AWS example bucket1 dot s3, that's the namespace, dot US West 2, because it's in US West Oregon region, dot amazonaws.com /photos/puppy.jpg, right? So now when you actually store an object like this, it is addressable using an URL, and you can embed this URL within your application. Okay, and your application will be able to read from this particular object and render that image on the screen, on the web page, or on your mobile application, or wherever it is, right? So that way, that is the reason why I was saying that this is designed for internet. Okay, this was designed grounds up for the internet world, unlike other object storages which are there, which needs additional programming, which needs additional customization to make it work on the internet. Okay, buckets serve several purposes. They organize the Amazon S3 namespace at the highest level. Okay, like this one. This is the namespace that you have, right? So where you have the bucket name. Again, those bucket names are unique across the world, right? And you can't, like for example, I create a bucket named, my bucket. Okay, my RPL bucket, right? I mean, if I've created that my RPL bucket, no one else can use that name. It's like a domain name, correct? Like you take a domain name, right? Where Amazon.com domain is already existing. So no one else can use that Amazon.com domain name for their own websites, right? So similarly out here, I have a bucket name, which I want to use for my own applications or my own purposes for storing my data. No one else can reuse that bucket name, right? It's basically it's an Amazon S3 namespace at the highest level. You see this? This is the Amazon S3 namespace, right? So s3.region.amazonaws.com, whichever region that your bucket belongs to, you have to replace this with the region. So basically, s3.region.amazonaws.com is the namespace at the highest level. They identify the account responsible for storage and data transfer charges, because this bucket that I've created belongs to my account. So any storage or data transfer charges will get charged to my account. They play a role in access control. I can give access or revoke access to a certain set of users on a specific bucket. They serve as the unit of aggregation for usage reporting, right? So now any usage is reported is on the bucket level, not at the object level, right? I create my RPL bucket that basically is the unit of aggregation for all my reporting purposes. Like I want to know how much data is there in the bucket, I can get to know. I want to know how much charges are coming to my bucket, it's at a bucket level. Okay, you can configure buckets so that they are created in a specific AWS region. You can also configure a bucket so that every time an object is added to it, Amazon S3 generates a unique version ID and assigns it to the object. Okay, versioning, right? And you can maintain multiple versions of the objects as well. So that's again another advantage of S3. Then come to objects, right? So you have the top level bucket, then objects. Objects are the fundamental entities stored in Amazon S3. Objects consist of object data and metadata, right? Like object data is the actual data that the object has, which could be a text file, image file, or whatever it is. And also the metadata about that particular object, such as what is the name of the object, who is the owner of the object, right? And things like that. So that's all the metadata of the object. The data portion is opaque to S3. When you say opaque to S3, S3 doesn't know what data is stored within that object, right? And S3 doesn't care. Amazon also doesn't care what data you store. You can store any data that you want. Okay, so Amazon only manages the metadata of the object, right? Again, the metadata is a set of name value pairs that describe the object, right? It's basically a key value pairs that describe the object itself. Okay, these include some default metadata such as the date last modified, like how you have, right? I mean, in your normal file system, you have date modified, created, right? And things like that, right? I mean, who has got permissions and things like that, right? That's all metadata. And then an object is uniquely identified within a bucket by a key and a version ID, right? So key is the name of the object, right? Like I already have an object within my bucket, my RPL bucket, as my object.txt or my file.txt. Okay, that my file.txt is unique, right? It's like a file system only, right? Because in a file system, you can have only the name of the file as like only once, correct? You can't duplicate it. It won't allow you to duplicate that with the same name, right? It won't allow you to copy because it says there's a file that already exists with that name. Similarly, here also, it's identified within a bucket by the name and the version ID. There's also version that it's a composite key where it also uses a version, right? So now in this case, I have my file.txt. I can have multiple versions of the file within the object, within the bucket. Okay. Again, a key. A key is a unique identifier for an object within a bucket. Every object in a bucket has exactly one key. The combination of a bucket key and version ID uniquely identifies each object. So you can think of Amazon S3 as a basic data map between bucket plus key plus its version and the object itself, right? So every object in Amazon S3 can be uniquely addressed through the combination of a web service endpoint. Okay, like bucket name, key, and optionally a version. Okay, for example, there's one example out given here. You have https doc.s3.amazonaws.com/2006-03-01 Amazon s3.wsdl. Okay. So if you see, doc is the name of the bucket, and what you see here, right? So this is the key, okay, which has the object, and basically the object itself is this one is the object. This is the prefix for the object. Okay. And coming, you will understand more of this when we do some lab exercises. For now, just sit back, relax, and absorb the concepts. So then comes the regions, right? So now the regions that you see, right, all the regions that Amazon AWS has, that applies to S3 as well. So now you can choose a geographical AWS region where S3 will store the buckets that you create. Okay, you might choose a region to optimize latency, minimize cost, or address regulatory requirements, right? Like say, for example, if I'm starting up a new startup company, I want to create an money wallet, okay, e-wallet, something like Paytm or Google Pay, right? And right now, if you see, there is a stringent regulations by Reserve Bank of India that any financial products that deals with Indian customers will have to store the data only in India. They can't store the data outside India, right? So that way, I want to basically create a startup and start a new service, like Paytm or Google Pay. Then, what I need to do is I need to basically choose Mumbai region, India region, right? Because I'll store all the data within Mumbai region. It will not go outside of Mumbai, right? So I will choose, for example, in this case, I'm using S3. Then I'll use Mumbai as the region to store my S3 data. Okay, and for two reasons, right? One is obviously latency will be lower because all my users are going to be in India, correct? So for them to go all the way to US East or Singapore or Australia, it becomes quite expensive, correct? The latency becomes quite higher. So I don't want to incur any latency, right? Latency, what is latency? Latency is the time round trip it takes for your computer to go talk to the server and fetch the data. If the data is in Mumbai, it's very close by, right? I mean, Mumbai is hardly less than 1,000 kilometers or whatever. I mean, it's within the 1,000 kilometers range, correct? No, not even 1,000. I mean, it would be around. Yeah, I mean, within India, if you take, it'll be about 1,500 kilometers reach, correct? Whereas if you go with, say, US East, it's several thousand kilometers, correct? Obviously, it increases the latency increases to fetch the data. We'll also address regulatory requirements. As I said, RBI has a regulation to store data locally within India. So that's why it is important you choose the right region. There's something called consistency model. I'll not get into the consistency model right now, okay? Because it's kind of, I'll explain this tomorrow in our advanced session. So there are several storage classes that S3 offers, right? Such as a standard storage class, infrequently accessed. There's something called Glacier, right? Where you feel that you don't need to store all the data at a standard storage class, because standard storage class is expensive, in the sense that is the I mean, S3 itself is a very inexpensive service. It's not quite expensive, but again, within S3, what Amazon AWS has done is they have categorized it into multiple different tiers. So that way, if you want to retain your data for a longer time, you are not using the data any longer, but for the sake of record keeping, just for the sake of retention period, right? Because every organization will have data retention policies, right? How many years they want to store the data, right? Like how banks have in India, correct? And banks have a policy where they retain your data for X number of years. The transactions that you have made will be retained for X number of years. They don't retain the transactions that you have made forever, because it's an additional storage cost, right? I mean, of course, they have to add more and more storage to their main OLTP systems to manage the data, which is going to be very expensive, right? So that's why if you see, maybe you can check, you can log into your bank account. Okay, 7 years old data, you won't be able to see transactions because they would have archived all the data. So now in S3 also, there is a way to archive the data. That's called Glacier. Okay, and there are again, standard is the general purpose storage, where it stores, that is the default storage. Beyond standard, you also have standard IA, infrequently accessed. That will be slightly lesser than standard, because in infrequently accessed, you are storing the data objects in a slightly lower tier, right? If you, for example, if imagine standard uses SSDs, underlying SSDs to store data and retrieve data, because at the end of the day, it has to go to a disk, correct? Some storage disk. So that storage disk could be SSDs, but in standard infrequently accessed, since you are feeling that, I mean, this data is hardly going to be accessed, but I want to keep it. I mean, if users do access, I want to basically give access to users to access the data, to retrieve the data. In such cases, you can prefer infrequently accessed storage tier, where the infrequently accessed would be probably stored in a magnetic drives, which is cheaper. So AWS is actually passing the cost benefit to the consumer, right? So where they don't incur so much cost on normal magnetic drives, like as much as they incur on the SSDs. And Glacier is for archiving long-term data, where you just go ahead and upload all the data into Glacier, which you feel you will only access it probably once or twice a year. So when you want to access it, you have to retrieve it from Glacier. Particular object, you have to retrieve it from Glacier. So there are charges associated with archival and retrieval. Apart from that, the charges are going to be very, very minimal. It's like a throwaway price. If you want to store data forever, you can store it. Okay, you want to store the data for like 100 years, you can store it. There's no problem with storing it in Glacier. It's for long-term market. There's one more storage tier called Deep Glacier. Deep Glacier is even more cheaper than Glacier. Okay, where you put it into a Deep Glacier, it'll just go into Deep Glacier and you can retrieve it from Deep Glacier at some point in time. Okay, so that's the various different storage tiers that are available. I'm just going back to S3, the home page of S3. Okay, I'm just going to show you this video, short video. Let's computer sound. Okay, so now let's all view this video. It's a very interesting video.
Companies today need to simply and securely collect, store, and analyze their data at a massive scale. But today's fragmented data storage portfolios force businesses to struggle with complexity and slow down innovation. That's why AWS storage services give you a place to store all of your data with unmatched durability, availability, and scalability. With a reliable infrastructure, tools for compliance, security, and storage management, a massive ecosystem of integrated third-party software and systems integrator partners, and that works with your business processes and even enhances those processes by allowing anyone to securely run queries of their data without moving it to a separate analytics platform. Amazon Simple Storage Service, or S3, lets you collect, store, and analyze data in any amount from anywhere. First, durability. With the largest global cloud infrastructure, Amazon S3 was built from the ground up to deliver 11 nines of durability. S3 Standard Infrequent Access, and Amazon Glacier storage classes store all of your data redundantly across 3 availability zones that are separated by miles on separate power substations and connected to other AZs and the internet on multiple, physically separate fiber paths, keeping data written to a single AWS region protected, even in the event of an entire availability zone loss. S3 One Zone IA gives you the option to store reproducible data in a single AWS availability zone, trading lower fault tolerance for lower cost. And with all of these storage classes, you have the ability to replicate that data to any other AWS region. Second, security and compliance features. S3 supports 3 different forms of encryption and offers sophisticated integration with tools like AWS CloudTrail for auditing. It's integrated with Amazon Macie, a machine learning service that can automatically discover, classify, and protect sensitive data. And it supports the security standards and compliance certifications that help satisfy compliance requirements for virtually every regulatory agency. Highly regulated organizations, like Capital One, say they can operate more securely in the AWS cloud than in their own data centers. Third, management. Amazon S3 gives storage administrators the most flexible set of storage management and administration capabilities for classifying, reporting, inventorying, and analyzing data. This means you can understand what data you have, make the best decisions about it, and automatically keep your costs down. Amazon S3 also works with AWS Lambda, so you can develop workflows without adding dedicated computing resources. Next, query in place. Amazon S3 lets you run sophisticated big data analytics on your data without requiring you to extract and move the data to a separate analytics platform. Anyone who knows SQL can use Amazon Athena to analyze vast amounts of unstructured data in Amazon S3 on demand. And with Amazon Redshift Spectrum, you can run analytics against exabytes of data in S3 and run queries that span both the data you have in S3 and in your Redshift data warehouses. And now you can even query data directly in Amazon Glacier, making archive data useful without requiring a restore. These query-in-place tools make it simple for anyone to use simple SQL commands against your entire data set. And even when application data increases, automatic scaling means performance stays fast. And finally, the partner network. In addition to integration with most AWS services, the Amazon S3 ecosystem includes tens of thousands of consulting, systems integrator, and independent software vendor partners, with more joining every month. The AWS Marketplace offers software pre-configured to deploy on the AWS cloud. This means customers can easily use Amazon S3 with popular solutions for backup and restore, archiving, disaster recovery, data lakes, and many more. No other cloud provider has more partners with pre-integrated solutions. Amazon S3 is the single place for whatever data your business needs to store, manage, and analyze. Start your AWS journey today at aws.amazon.com/S3.
Okay, so quite an exciting, interesting video, isn't it? So a couple of things that I would like to highlight here, right? So one is they spoke about exabytes of data, right? What is exabyte of data? Exabyte. Okay, what is exabyte? Exabyte is 10 to the power 18. Okay, so 1 exabyte is 1000 petabytes. Okay, and how much is 1 petabyte? 1 petabyte is 1000 terabytes. Okay, and what is 1 terabyte? Is 1000 gigabytes. And what is 1 gigabyte? Is 1000 megabytes. 1 megabyte is 1000 kilobytes. Okay, so now that's the scale, right? So 10 to the power 18 is 1 exabyte. Imagine it's like 1000 petabytes. Petabyte scale itself is a huge, okay? Like petabyte scale is quite huge in its size and in its volume and in its scale. Okay, so now it basically creates a it's an exabyte scale data storage on cloud. It is S3 and 11 nines. Okay, so now let me just ask you, how many of you know the SLAs? What is an SLA?
Service level agreement.
Service level agreement. Yeah, that's correct. So it's called service level agreement, right? Like for example, I have an SLA defined. Okay, I'm creating a new service and I want to basically have a service level agreement defined for that particular service, right? I mean, it applies to anybody for that matter, right? For example, like the online food ordering platforms like Swiggy, Zomato, and all has got a service level agreement, right? Within half an hour, they deliver your food. Okay. Similarly, Amazon.in also has got service level agreements. If you have a Prime membership, or forget about Prime membership, if you order an item in Amazon.in, they say that the order will be delivered within so and so date. Okay, so that way you have service level agreements defined for every service, And at the same time, you also have the so in the case of cloud, the case of digital world, right? Service level agreements primarily is around the durability, especially for the storage, right? How durable your storage is, right? What is durable? Durable is, I mean, what is the, will you have any data loss? Like I'm storing huge amounts of data. Will I have any data loss? How durable is my data going to be, right? So in this case, the durability is 11 nines. Okay, what does this 11 nines mean? 99.999999999. That is like 11 nines. Okay, it's usually 100%, right? But nobody can, give a SLA of 100%, because if you have to give a SLA of 100%, then you need to be able to test it. You'll never be able to test 100%, right? Can anybody say a system will be available 100% of the time? No, nobody can say that. In fact, that's where the thing comes in, right? Where it is not possible that a system can be up 100% of the time, right? Some time or the other, systems can go down, but again, how resilient you have built, how resilient is your architecture, defines how your system responds to events and responds to disasters. So because if you have to commit on 100%, then first of all you should be able to test it. Unless you test it, you won't be able to commit it, correct? You will never be able to test it, right? Because how long you will test? You will test it for 1 day, you will test it for 2 days, because time is continuum, right? I mean, time is never ending, right? You'll never be able to test it against the time, because again, availability is the x-axis is time, y-axis is availability. So in the x-axis, the time is never ending, right? You'll never be able to test it. You'll test it for 100 years, 200 years, 300 years, 1000 years, 2000 years, million years. No, you will never be able to test it for an infinity, correct? So that's why it's always an SLA is defined as nines, 99.99% or 95%. Okay. In fact, there are sites available where you can calculate the SLA calculator, right? I'm going to just show you SLA calculator, not XLA, sorry, availability calculation. Uptime.is, okay, system uptime.is. It's one of the famous sites that you have, right? And if you see agreed SLA level, if you have 3 nines, this means 3 nines, which means 99.9%. Which means if you're agreeing to an SLA of 99.9% for uptime or availability, which means in a day, 1 minute 26 seconds of downtime is allowed. Okay, in a week, 10 minutes 4 seconds is allowed. In a month, 43 minutes and 49 seconds is allowed. In a quarter, 2 hours is allowed. In a year, 8 hours of downtime is allowed. Okay, so when you commit 99.9% of uptime availability, in a year, you can take it down for 8 hours, which means that you're well within the agreed SLA, right? If you make it 99, yeah, when you make it 99, daily only 8 seconds is allowed. Yearly only 52 minutes is allowed. If you make it if you make it 5 nines, yeah, 5 nines is even like negligible, right? I mean, it's going less than 0. So daily 0 seconds. You can't have a daily downtime. You can have a weekly downtime of 6 seconds, monthly downtime of 26 seconds, yearly 5 minutes downtime you can have for 5 nines. So let us do it for 6 nines. 6 nines is yearly 31 seconds. 7 nines, yearly 3 seconds. 8 nines, yeah, it's again even going into negative. So that way, if you put 11 nines, it's pretty much like 0 downtime or 0 loss of data, pretty much 0 loss of data. Okay, that's what your calculations say. Okay, that way you have, because these are all interview questions, friends. I mean, you have to understand this. People might ask you, S3 is designed for what, how many nines of durability? you should immediately say 11 nines of durability. Okay, which means 99.999999999 11 nines of durability, and stores millions of applications for companies all around, right? So that way, these 2 points are important, where S3 supports exabyte of data, and S3 is also used for like big data, data lakes, building data lakes for big data, right? I mean, where you don't need to store, go behind a separate database. You can store objects in S3, and use S3 also provides you an ability to basically issue a simple SQL command to query data from S3. Okay, we are going to see all of that. You can just simply use an S3, simply use a SQL query, like what you all did during your first week, right? So where you all worked with Oracle PLSQL, where you wrote SQL queries to query data from a database, right? Similarly, from S3 also, though it's an object storage, there are ways to query data from S3, which you can use it in your big data driven application. So there are data lakes. Companies have built data lakes using S3. Okay, because it's very cheap, right? And what is the pricing of S3? Okay, before that, I'll just go to storage classes. I spoke about the storage classes. So these are all the storage classes that S3 offers. The standard storage class, standard intelligent tiering. Intelligent tiering is where if you enable intelligent tiering, it automatically decides if your users are not using objects that frequently, it will automatically move it from standard to standard IA or one zone IA. Okay, and the third point that you need to observe there is, the first thing I said was 11 nines. Then it is exabyte of data, exabyte storage of data. How Amazon, AWS manages that 11 nines is, if you store an object in a region, in one of the buckets in a region, that region has got every region has got a minimum of 3 availability zones. Okay, that's like standard 3 availability zones. So what AWS does is, it actually replicates that object in 3 availability zones within that region. It does not take it outside the region, because it can't take the object outside of that particular region or that particular country, correct? So it stores that object in all the 3 availability zones. So that way, if one of the object goes down, right, or if one of the object fails, it can simply replicate the object from the other 2 availability zones, and always maintain 3 copies of the object in 3 different locations. So that way, the durability is very, very high. Durability is pretty much, I mean, you store the data, you can store it forever. Okay, you can pass it on to generations, you can store it forever. That is the thing. So that way, what AWS gives us, they give a standard tier where it stores it in all the 3 availability zones. But if you want to reduce the cost, you can also prefer to choose it only in 1 availability zone. Okay, so that way, you reduce the cost a little more. You feel that, okay, even if I lose the data, I'm okay, I don't care, right? You can just store it in 1 availability zone. And then Glacier is the archival. Deep Glacier is again one more level of archival for further reducing the cost. Outpost, don't worry about it right now. Pricing, I'm just going to the pricing. So if you see, go to pricing, let me select Mumbai as a region. So every service will have a pricing tab. You can just see what is the pricing of every service, right? So if you see, I've just selected the, and there are different heads of pricing. Okay, one is storage is one of the heads. The other head is request and data retrievals, because the number of requests that you make to S3 and the amount of data that you retrieve, that is also chargeable. Then data transfer is charged, and management and replication is also charged. For example, you want to replicate, you have a bucket in Mumbai region, and you want to replicate that bucket to US region. I mean, provided your compliance and regulatory allows it to do so. Okay, you can just go ahead and replicate that data across multiple regions. That is charged. So now, if you see S3 standard storage, the first 50 TB per month. Okay, it's all stored and it's all charged in a monthly basis, like any other service, right? Even if you go for Dropbox, or if you go for any other Google Drive, if you purchase additional storage, you pay it on a monthly basis, right? So here also you pay it on a monthly basis. So for the first 50 terabyte, it is $0.025 per GB, which is 0.025 is how much? It is it is probably less than a cent per GB. Okay, it's like 1/4 of a cent. Okay, you have 1 paisa, right? It's like 1/4 of a paisa per gigabyte is what is stored. Just $0.025 per GB. Okay, then next 450 GB, it's like your electricity metering, right? They'll say that first 200 units, 5 rupees. Okay, from 200 units to 300 units, it's actually reverse. They charge more in our electricity, right? So they say if it is 5 rupees for the first 200 units, then for the next 200 units, it's 10 rupees. But here it goes down actually. Okay, if you see for the next 450, the more and more data you store, the less you pay. Okay, that is 0.024 per GB. Then over 500 TB per month, it is 0.023 per TB. Okay, then S3 intelligent tiering, right, where frequently accessed for first TB 25 025 024 023, and then 0.019. Similarly, you can just review all of this. Okay, so now I want to show you something, right? So now if you see infrequent access, it is 0.019, right? Compared to your standard, which is 0.025, your infrequent is 0.019 per GB, which is like quite inexpensive, correct? Then you have one zone. If you want to just store the data in only one availability zone, then it is even more cheaper. It is 0.0152. Okay, now if you come to Glacier, oh my God, see, Glacier is even more cheaper. If you see, it is 0.025 and Glacier is 0.005. Like it is like how much? If you, okay, 1 rupee is like 100 paisa, right? If you break 1 paisa into 100 sub paisa, it is like 5 sub paisa. Okay, that is the cost of storing the data in Glacier, which is like 0.005 per GB. Deep Glacier is even more. Deep Glacier is like 2 sub cents. If $1 is 100 cents, if you break 1 cent into 100 sub cents, it is like 2 sub cents. Okay, so that's basically the cost out here. If you want, I'll introduce you to one more thing called calculator.aws. Go to this calculator.aws. You'll be able to create an estimate, right? Click on create an estimate, then search for S3 and click on configure. And here you can just select the region. I'll go with Mumbai region, change the region. Okay, here what I'll do is I'll just I can select whatever that I want my billing, whatever my estimate to have. This is just a simple calculator tool to give you an estimate, right? So when tomorrow when you go and you have customers, when you all are all in jobs and you're going and meeting your customer is saying, hey, I want to understand what is the cost that I'm going to incur. You can quickly use this calculator to show the customer that, okay, Mr. Customer, this is the cost that you're going to incur. This is the rationale for it. These are the estimates, right? This is like an estimator, like a calculator, right? So I'll go for S3 standard and S3 Glacier and Deep Glacier. Okay, these are the 3 things that I'm going to go for. So here I'll just store, okay, the customer would want to store 500 GB per month. Okay, I'm just giving, forget about all of this. Just he wants to store that 500 GB per month. So with the standard storage, the customer would incur $12.5 per month on the standard S3 storage. Whereas if he wants to go with Glacier, okay, he wants to archive it. He thinks that, he wants just a place where he wants to archive. Customer has got a lot of data within his organization, and he's looking at a very inexpensive mode of archiving all his data, right? Where you can actually propose Glacier. Okay, you can say that, Mr. Customer, you can actually put it in Glacier. It is durable. It is 11 nines durable, and you can just store as much data as you want for a very throwaway price. What will be the price? $2.5, right? So whereas if you see the standard is 12.5, whereas If you put it in Glacier, it is $2.5 per month for 500 GB of data. Okay. In fact, you can also store data into Glacier, right? I mean, like if you put TB per month, right? I can actually store, 1 TB of data into Glacier for $5 per month. So $5 is like 350 rupees per month. Okay. But if you want to put it in Deep Glacier, you can also put it in Deep Glacier, Deep Archive. So Deep Archive, I'll put Deep Archive. I'll put 1 TB per month, $2 per month. So 1 TB, you can actually put it into Deep Glacier for $2 per month. $2 is 150 rupees. 150 rupees is like throwaway price, right? And you can just store. I mean, imagine how we all take a lot of photographs. We collect data over a period of time, right? Our digital footprint is just increasing on a day-by-day basis, right? So when your digital footprint is increasing, you want to basically store it somewhere safe and secure, which you can access anytime. You can just go ahead and put it into Deep Glacier for $2.50 per month. For $2 per month into Deep Glacier, 1 terabyte, you can just put it in Deep Glacier. Okay, I'm just talking from an individual perspective, but for enterprises, this is even more. It makes sense for enterprises to actually store their petabytes of data into S3, right? I mean, for example, company has got, say, 1 petabyte of data. Okay, 1 petabyte is 1024 terabyte, right? 1024. They only need to incur about $2,000. But imagine storing that 1 petabyte in a traditional storage within the enterprise. It would be hundreds of thousands of dollars. Okay, but that's the benefit of going with S3. And S3 gives you a lot of features and a lot of benefits, right? A lot of benefits that we just spoke about. Okay, so now let's do one thing. I'm sorry, just give me a second. Yeah, so yeah, that's the benefit of S3. I think all of you kind of got a sense of what S3 is all about. Now let's go and do some stuff with S3, right? I mean, let's just go and play around with S3. Okay, so now how do you navigate to S3? You log into your AWS account. Once you log into AWS account, as usual, just go here, search for S3. Just see S3, you will see S3 Glacier. You'll see multiple other things which are related to S3. Select S3. Yeah. So once you select S3, you will get this page. Okay. So there are two things that you need to observe very closely, right? Number one, you get the very similar interface that you see for other services, right? And you will see one more thing out here. You will see by default, when you select S3, and when you go, it will switch to global, and you won't be able to select a region here because S3 is a global service. The data that you store in S3 is regional, okay, which is stored in a region. Like for example, I've created 2 buckets that's within the region, but the data, but S3 itself is a global service. Sorry, just give me a second. Let me open my another account. So that's where if you see, it's going to be very, very important for you to understand global service. Similar to IAM, right? When we created IAM, when we went into the IAM page, IAM is a global service, right? You won't be able to specify something at a regional level in IAM because IAM is global. It is for your account. Whatever resources that you create, you'll be able to administer all those resources by giving access through IAM. Okay, back here. So I'm just going to S3, right? So if you see, the moment I go to S3, I see that this is like global. Okay, and I don't have any buckets right now, right? It's like empty. Okay, and you can create a bucket by clicking on create bucket, right? And you can see other things such as batch operations, access points. All of those are advanced settings. We'll come back to that later. But I'll just go and click on create bucket. Okay, so now when I create bucket, again, it is at a global level, right? Because the namespace of the bucket, right, which is the bucket name, is a global bucket name. As I said, I create a bucket name, I give a name to a bucket. It's a unique name, right? Because the bucket name, as I said, has got 3 elements to it, right? The bucket name itself, the region, right, and the version, right? So that's kind of forms a unique thing to the bucket. Okay, I'm just going to create my RPL bucket. I hope no one else has taken it. Let's see. Okay, and then I'm going to select the region as Mumbai because I want the bucket to be present in Mumbai region, right? Let me just open our good old whiteboarding. I'll just show you quickly how the concepts apply. Okay. So this is your AWS region. And one more thing, your VPC does not apply to S3. Okay, it does not store any of your data within your VPC. Right, VPC and S3 are unrelated to each other, so don't get confused with VPC. Okay, because AWS S3 is a fully managed service. You don't have to manage anything in S3. You only have to manage your data. Right, you don't have to manage any underlying infrastructure or any of the underlying resiliency or high availability. You don't have to manage anything because it's a fully managed service, right? It's like this. Do you manage any of the underlying infrastructure for your Dropbox or Google Drive or OneDrive? No, it's the similar way. Okay, first is region. I'll say Mumbai region, right? So this is the Mumbai region, right? So this is my Mumbai region. This is my account basically. This is my AWS account. And this is my region. Okay, this is my AWS account. This is the region Mumbai. So within Mumbai region, I can actually create an S3 bucket. I'll just search for the icon for S3 bucket. S3 bucket. I create a bucket. This is, by the way, the official icon for S3 bucket. I create on S3 bucket named my RPL bucket. That is the name of my bucket. Okay. And then I can store any objects into this, right? Just store any object there inside. I can store multiple objects within my RPL bucket, right? So now if you see this name, my RPL bucket is basically a unique name across accounts and across regions. That's very, very important for you to understand. Okay, now assume there is one more account. Okay, 987654321. That is the account, another account, and this is like US East 1, which is North Virginia, right? I cannot have the same my RPL bucket in another account in another region. Okay, it will not allow you to create this. You have to give some other name to this. Maybe my RPL bucket 1 you have to create. So always imagine always remember these are unique names. The bucket name is very unique because of the reason why. Because when you actually refer to this bucket, because as I said, S3 is designed for internet, correct? So you should be able to actually say, for example, there is an object inside my S3. Let's assume this object name is hello world.txt is my object that I have. Okay, this is the object that I have, hello world.txt. Okay, so now how will I access my object within this bucket? The way I will access it is using a URL. I would say https:// my RPL bucket .s3 dot Mumbai, right? So ap-south1 dot Amazon AWS.com / hello world.txt. This will be the unique URL for me to access my object. Okay, so now what you have here is, I mean, this is basically a DNS fee name that AWS creates, right? So it does not allow you to create that in multiple other places or multiple other locations or multiple other accounts, because that bucket name that you have is your bucket name, right? I mean, you can't really modify it. It's like creating a domain name only. Okay, so similarly here, how will you represent this? It will be my RPL bucket 1.s3 US East 1 .amazon aws.com. You can still have the same object name. Object name can be same. It's like two different folders, right? In your computer also, you go to two different directories, two different folders in the same subdirectory, or in C drive, just go create folder 1, folder 2. You can't have two folder ones within the same subdirectory, right? You have to have folder 1, folder 2. Within folder 1, you can have hello world.txt. Within folder 2 also, you can have hello world.txt. But the main folder name has to be different because they're all within the same namespace. Okay, so that is the difference that you all need to understand, that one bucket name has to be unique across world, across various AWS accounts. You can't reuse the bucket name within AWS account. Number one, you can't reuse bucket names across AWS accounts. You can't reuse bucket names across the world. If I have claimed a bucket name, that's it. I've claimed it. No one else can use my bucket name because bucket names are global in nature. Okay, please understand that very, very clearly. It's very important you get this concept. Otherwise, you will think that, okay, I've used a bucket name and you can try it out actually. Okay, let me just go ahead and create my RPL bucket. I'm not sure whether it is there or not. Let's see. If you see, bucket names must be unique and must not contain spaces or uppercase characters. You can click this, see rules for bucket names. Let's review those rules quickly. Bucket names must be 3 and 63 characters long. You can't have a crazy name for your bucket. Bucket names can consist only of lowercase characters, no uppercase. Okay, only lowercase. Numbers, dots, and hyphens, no other special characters. It cannot have other special characters in the bucket names. It can have numbers, dots, uppercase, and hyphens. It can't have underscore, dollar, nothing of that sort. Bucket name must begin and end with a letter or a number. It cannot, towards the end of it, it can't have a dot. It cannot have an hyphen. Bucket names must not be formatted as an IP address. Bucket names can't begin with xn hyphen for buckets created after February. See, in what AWS did was AWS basically made a very standardized rules after, like, say, February recently, right? February 2020, and also they enforced the usage of SIG v4. The other day when we looked at IAM, I told you about SIG v2 and SIG v4, right? Signature for signing your API requests. So now SIG v4 is the latest method for signing API requests, and AWS has made that mandatory for any buckets that are created after February. Bucket names must be unique within a partition. A partition is a grouping of regions. AWS currently has 3 partitions, which is AWS China, and AWS US Gov, right? So what we had here is, this is the partition, right? AWS.amazon.com, right? So that's the partition. Currently, we are all on AWS partition only, right? I mean, all that we are doing, lab accesses, everything is within the AWS partition. So that way, AWS, it has to be unique within AWS. So forget about China and GovCloud. We are not dealing with China and GovCloud. So we're only dealing with AWS, which is the standard regions like Mumbai, US East 1, US West 2, and all of that. Okay, so imagine, remember that. So I'm creating my RPL bucket, and then you will have some settings here, such as block public settings for settings for public access, right? I mean, if I say block all public access, bucket won't be accessible publicly. Okay, nobody will be able to access the bucket. Okay, this, if I need a bucket to be private bucket, where only my users or only whoever users have got authentication will be able to access the bucket, then I'll have to uncheck this and do that. And then versioning, I want to enable versioning or disable versioning. Okay, I can do either enable or disable. I can change it later also. I'll give a tag to it. I'll just say name my RPL bucket. Default encryption. If you want, you can encrypt the objects in the bucket. Okay, whether the server-side encryption is enabled or disabled, you can do that also. If you say enable, you have to use your keys to encrypt your objects. We'll come back to that. Those are advanced settings. Okay, and then object lock. Okay, this again is a warm model. I'll talk about this later. For now, just ignore it. Okay, so what we have seen the bucket name, which is a unique across world, across accounts, across regions. And I will create my bucket in my region, because it's an object, right? I mean, it's a physical entity. It has to go in some data center, correct? And then I can block access, public access to my bucket, right? It's like giving access to your bucket to public. Anybody can read the bucket or not, right? If I just remove this, anybody can read the bucket. And then versioning, I have enabled versioning or disabled versioning. You can give a tag. You can give a tag to it, name. I'll just give one more tag, purpose. RPL training. And default encryption, I've just kept it disabled. So I'll just go ahead and create bucket. Okay, somebody has taken it. Some smart person in this group has taken that my RPL bucket. Good. So who has taken the RPL bucket? My RPL bucket. I'm going to give my RPL bucket. Today is 9th November, right? I'll just say 9th November. I don't think anybody would take this. Just say create bucket. Yeah, so I've just created a bucket called my RPL bucket 09 November, because while somebody has taken the my RPL bucket, I mean, maybe now, or I don't know, previously. Someone must have tried creating a bucket. So somebody has taken this. So that's a good example, right? So where it has to be unique. The bucket names have to be unique. Bucket names, once it is taken by somebody, it can't be claimed by someone else because it is unique. And once you use the bucket name, so now no one will be able to create a bucket name with the name as my RPL bucket 09-November. Okay, so that's the beauty of S3, and that's where you basically get this. So now you got the bucket created. So you go inside the bucket, you see all of these options here. Okay, you see multiple tabs. Okay, intentionally it's all kept very simple and robust. You have a tab called objects, where this is where you can upload, download objects, or you can create folders. This is the versioning, right? You can enable versioning or disable. Right now it is disabled, but I can enable. And I can also have a multi-factor authentication delete, right? Say I feel that my S3 bucket is very, very sensitive. The data that is present within the S3 bucket, I don't want users to just go ahead and delete it just like that. So rather I want to have an MFA delete, right? So where user multi-factor authentication, like all of you have done for your IAM users or root accounts, where you have a authenticator, Google Authenticator, and only if you put the code, it will get deleted. You can also do that. Tags are there. The encryption is disabled. Can enable server access logging. Can enable CloudTrail. All of this will come back to it later. But for now, just understand that there are multiple properties that you can control your bucket with. Permissions. Block all public access is on, which means that all the public access to this bucket is enabled. So the public access is disabled. I mean, I'm not giving any public access. So which is block all public access is on, which means that it is disabled. Then metrics is where you can see the total bucket size, total number of objects and things like that. You can go to management, and management, you can see lifecycle rules. We'll come back to this later. Access points also come back to this later. Now I'm going to actually upload an object. You can just drag an object and put it here, or I can also upload an object. So I'm just going to go here. I'll create a new file. I'll just create a new file that says hello RPL champs as an object. I'm just going to save this into my RPL folder. Okay, I'll just save it here itself. Hello RPL, save as hello world dot. I'll just go back one folder. Yeah, I have hello world.txt here. What I can do is I can simply drag and drop, or I can upload it. Right? When I say upload, add files, hello world.txt. I'll just say open. Yeah, it will just add it to this. I'm adding it to my S3 bucket. S3, this is the destination where I'm uploading. If you see S3://, so this is how you represent the buckets. If you hover on top of it, you will see that it basically gives a on the bottom. On the bottom, just observe this bottom portion. It will actually show the namespace of that, where it says s3.console.aws.amazon.com buckets, my RPL bucket 09 November question mark. So you have a query string region equal to AP South 1. Okay, so yeah, I mean, don't worry about other details, just click on hit upload. Yeah, so the object is uploaded. So if you see, the object is uploaded here. You have the files and folders, which is like total of 19 bytes. Hello world.txt is uploaded to my bucket. I'll just go back to my buckets. I click on this, I see my objects. I have one object uploaded to my bucket, which is hello world.txt. Okay, if I click on this hello world.txt, it will show me the details about this object. So this is the metadata of this object, right? So where the metadata of the object is the unique URI, unique resource identifier is s3:// my RPL bucket 09 November / hello world.txt, like how I gave you here, / hello world.txt. Okay. And then the region that it belongs is Mumbai. And what is the Amazon's resource name for this? Again, ARN is a unique, right? So this is the Amazon resource name, AWS :S3 3 : my RPL bucket 09th November hello world.txt. Okay. And then what is the last modified is November 9th, 2020, 10:32 AM local time. Size is 19 bytes. Type of this object is it's a text file. Key. What is the key? Key is the name of the object, right? Which is hello world.txt. E tag. E tag is a unique identifier, which is to, I don't know how many of you know what is a checksum. Okay, in a file, a checksum is basically a unique checksum, MD5 checksum, which is a combination of, right? So for example, when you modify the contents of a file, the unique MD5 checksum of the file also changes. So that way, you want to ensure that the file that is there in the source and the file that gets copied to the destination are one and the same. You have to use the MD5 checksum, unique checksum of a file. Okay, if in fact, if you go to certain objects, certain websites, right? Say for example, you want to download, say Java, right? I'll just show you. Download Java. You go to Oracle website, right? So if you go to Oracle website and you go to download Java, you just go to the Java download section. Okay, but before that, I want to basically see what is the checksum of that Java file, right? You just go to see all Java downloads. Site has got the checksum with MD5 checksum. Okay, I need an account to log in. Okay, yeah, I'll just go to download CentOS. Okay, I'm not able to look up, but what you can do is you can actually go download Java. In that Java Oracle page, you will see that MD5 of the file which is given. So once you download the file, you can verify the original MD5 checksum with the copied MD5 files checksum. Okay, so that way you can match it. If it doesn't match, which means that somebody has tampered the file while the file was in transit, right? It's always possible, right? When the file is actually getting transferred from, say, source to destination, there could be a virus which is sitting in the middle in your destination computer or in the source computer, which is injecting some malicious code into the file, which is basically modifying the file contents. So the moment the file contents gets modified, it means that the MD5 checksum of the file also changes as part of that, right? Because that's a unique file which is to identify what is the contents of whether the contents of the files have been modified or not. Similarly, here also, this E tag is basically a combination of your object, which has the if your object properties change, this E tag also changes along with. So that way, you know that you have a mechanism to validate whether the original object is there or somebody has modified the object or not. Okay, so that's E tag, and this is the URL. As I said, my RPL bucket .s3.ap south1.amazon aws.com/hello world.txt. This will be my object URL, right? Now, if I click the object URL, it's going to give me access denied because I have not given access to anybody to this object, right? Only, I have not given a public access to anybody, so I won't be able to actually access it using that https:// my RPL bucket, right? Okay, so now let's just do some more things with this bucket. I'm just going here, and I'm here out here on properties. I'm just going to go and change some of the properties or permissions. First, let me change the permissions of this bucket. So right now, I've blocked public access to this bucket. I'll just go ahead and edit it. I'm going to turn off this. Okay, through this, I'm going to give public access. It will ask for a confirmation because the moment you make a bucket public, anybody can access it using that URL. You have to remember that very, very clearly. Anybody in the world can access that bucket using that URL. Okay, so that's why it'll give you a small warning. It says updating the block public access settings for this bucket will affect this public bucket and all objects within. This may result in some objects becoming public. Yes or no? Because it's actually warning you, because the moment you make something public, anybody can access it, right? Because that's the whole idea of making it public. In fact, that has happened. Quite a few customers or quite a lot of enterprises keep unintentionally make their buckets public, which has got some sensitive customer data in it, right? The moment they make that bucket public, hackers are waiting to keep looking for buckets that are getting public. The moment that bucket is made public, hackers can immediately log in, take all the data away. Okay, this has happened several times. I mean, you can Google for incidents, data leak incidents due to S3 public access. Yeah, see this. You can read these articles. Okay, again, you have to understand AWS offers shared responsibility model, where AWS ensures their portions of security. Your portion of security, which is in your control, you have to manage that properly. You cannot mismanage it. You can't afford to mismanage it. If you mismanage it, AWS will not be able to protect your data, right? So in this case, this is my responsibility, right? I mean, I'm just going to my bucket because AWS can't change the permissions of my bucket, right? AWS has given the infrastructure for me to host my bucket. But at the end of the day, if I go to log into my console and then edit this and make it remove the block all public access, and then I say confirm, I'm taking this decision on my own, right? AWS can't help it. Now I have to apply, my judgment to see whether I can make this bucket public or not. Okay, so that's AWS won't be able to make that decision on your behalf because it's your bucket, your data. It is not AWS's bucket or AWS's data. So you have to understand that very, very clearly, right? Now I'll go ahead and object. I still have to make my object public, right? So my bucket is public, but my object is not public as yet. Okay, for that, if I have to make my object public, I go here, I click on actions. I just say make public. Yeah, just make public. My object is also public now. Okay, so I'm just going to my bucket. I'll just select my object. I'll click on this URL. Yeah, so now it can see hello RPL chance. It's actually giving my text file. I can download this also, right? If I say right click and say download, save link as, yeah, I can just say download it and just put it in my desktop. It'll actually download the object to my desktop. Yeah, I'll just go to my desktop. Yeah, see hello world.txt is downloaded. So if I just open it, see hello RPL champs is downloaded. You can also download it. So if you just go to this one, anybody can access it. I'll post it in the chat. All of you can try to access this object. I've posted it in the chat. If you're able to download it, just let me know. Or if you're able to access it, just let me know. Just you can copy paste that URL in a browser, you'll be able to access it. So how many are able to access it? Raise your hands. Okay, so many of you are able to access it, correct? Okay, very good. That's nice. Okay, cool. So now what we have done is we have created a bucket and we have made that bucket public, and I've created a bucket named I initially wanted to create my RPL bucket, but I didn't have that bucket name available for me to create. Someone else had taken it. So I then modified my bucket name as my RPL bucket 09 November, 9th November. And then I uploaded an object to the bucket. Okay. And I made the bucket public by removing block all public access settings. Then I also made that object public so that anybody can access my object which is present within the bucket. Okay, so now how users are able to access the bucket is because it has got a public endpoint available for that object, right? At the end of the day, when I hit the public endpoint, it makes an API call, it gets the object and it returns the object to the end user. So at the end of the day, it's like an API that is being invoked behind the scenes when I hit on this URL. When I hit on this URL, my RPL bucket 09.november s3 ap south1.amazon/helloworld.txt. There's an API call that goes behind the scenes. Okay, so now I can also do one thing. I can go back to my bucket. I'll enable versioning. I'll just go here. I can just say bucket versioning. I'll say edit. I'll say enable. I'll say save changes. Okay, so now bucket versioning is enabled. So now what I'm going to do is I'm going to modify the same hello RPL champs. This is version 2. Version 2. I'll save this and upload the same object again once again. I'll say upload, add files, same hello world.txt. This is version 2. Upload. Yeah, so it's uploaded, right? So now I'll go back to my bucket. I'll go back to my objects. If you see, select the object and then you refresh this page. Okay, because now again it will give an error because the object properties have changed. I have to make the object again public. I'll just make it public. I'll just make it public. I'll just go to the object hello world.txt. I'll just navigate to this. Yeah, see, this is version 2, right? So because I've overwritten the thing, right? So now what I can do is I can also see the versions of the object. I'll just go back here. So if you go to the second tab in that bucket, you will see the version of that object. See, the first version I updated at 10:32 a.m. Second version I updated at 10:47 a.m. First version is 19 bytes. Second version is 38 bytes. This is the version ID. This is the current version. This is the latest version. If I want to open the previous version, I can actually go and click on the previous version. It gives me that. I can download this version also. See, this is hello RPL champs, where I pass question mark version ID equal to null. I can give a version ID actually, version ID 1, 2, 3, something like that. If I don't give any question mark version ID, I don't pass any query string. It is just going to take the latest version. Okay, let me add one more version. This is version 3. I'll add this and then I'll upload that object. Upload, add files, hello world.txt, open, just say upload. It's uploaded. Once it's uploaded, the property of that changes. I have to go and make it again, make public. Okay, so now this is the first version. This is the latest version, which because I'm not passing any query string. So now let's see the second version that was uploaded, right? Just go here. Objects, select the object, go to versions. So you'll see three versions here, right? This is the first version, this is the second version. This is the third version, which is the current version. I'll just click on the second version. And this is the version ID, right? Some random string that it has taken. Yeah, so this is version 2. This is the first version. This is the third version. This is second version. So that's how you manage versioning of objects within the S3. Okay. So yeah, it's important you understand this, right? So that you can decide whether you want versions or not. And if you want to say list versions, it will list all the versions in the main page itself, right? And then if you want to delete, you can just select, I'll just remove it. Or to just delete, select the option, this thing, and then say delete. It's just going to delete. Yeah, but you have to give a confirmation, say delete objects. Okay, I'll just say delete. Yeah, I've just deleted the objects. If I go back to my bucket, yeah, there were no objects in my bucket any longer. If I just go and refresh this, okay, it is coming from the cache, my browser cache. It will go away in some time. Okay, it'll just go away. Yeah, it's gone. Yeah, it'll just go away in some time. Okay, so that's how you deal with S3 buckets and objects, right? And also there's one more thing that you need to understand is the operations that are performed on S3, right? So there are requests, right? So there are requests that you do, right? I mean, so at the end of the day, these are REST APIs, right? I mean, AWS S3 works on REST. So in HTTP REST, you have get, put, post, list, copy, select, right? So these are all the methods that are possible, right? So now the way S3 works is for the data that you store, obviously there is a data storage charges that AWS charges you. But apart from that, the number of operations that you perform on the object in terms of the number of retrievals, a number of post, which is like put and post, right? So where it is you're copying, copying files to the S3 bucket. So that is also charged. Okay, how it is charged? It is charged like this. See the standard tier, right? S3 standard tier. Now in this case, when I went to my S3, see, by default it is standard. You won't be able to create anything which is like not the standard one. I'll not get any choice here. Your entry point is always standard because you have multiple other tiers also, right? S3 standard, intelligent tiering, infrequent access, one zone infrequent access, S3 Glacier. Okay, so now you have to move from standard to any of these using lifecycle policies. But by default, when you create a bucket, it will be always standard. It will always go as a standard bucket. After that, from standard, you want to move to intelligent tiering or infrequent access or one zone infrequent access or Glacier. You have to create lifecycle policies that will allow you to modify. But by default, when you go and create a bucket, you don't get a choice to say that, okay, directly take it to Glacier. No, you won't get that. You won't be able to directly take a bucket, make it as a Glacier bucket. You won't be able to do that. By default, everything is a standard bucket. From here, it gets transitioned from standard to intelligent tiering or infrequent access or Glacier. That's very, very important. You have to understand that. Okay, so don't get confused with that. So from that perspective, if you see, if you go to this one, yeah. So if you see, for standard, per 1,000 requests, you are being charged 0.005, okay, which is like probably subcent. In a subcent, it is like 5 subcents. Or okay, that is for every 1,000 requests that you make, AWS is going to charge you 5 subcents. Okay, and similarly for get set and for get select and other requests per 1,000 requests, it is even more cheaper. If you see, write is little expensive, right? Here for write, all this, right? Put, copy, post, list, these are all writes. This is reads. Reads is like even more cheaper, 0.0004, which is like per 1,000 requests, AWS is charging you 0.0004. That is the charge that AWS is actually giving. Okay, so let's do a bit of a calculation. Okay, where I'll go back to my calculator. I'm just going to show you in this case. Let me just remove everything. Just remove all of this and just keep only S3 standard. I'm using like 500 GB per month. I think that, you know, maybe in a month, I would have about, say, 10,000 writes to my S3 bucket. For 10,000 writes, I might have like 10,000 new objects maybe copied to my S3 buckets. Okay, 10,000 new files. Okay, let's keep it as files. And about 50,000 reads will happen to my S3 bucket. Okay, 10,000 writes and 50,000 reads. And how much data will be selected? Maybe 5 GB per month. And how much data will be scanned? Maybe 200 GB per month. Or ignore this for now. I'm not going to keep it for now. Okay, so now what you get is 10,000 put requests, right? Which is write, and 50,000 get requests, which is read. So what you get is per 1,000 requests, it is 0.005, which means per request, it is 0.00005. 0.00005 US dollars per request, which is, in this case, for 10,000 put requests, I'll be charged 5 cents, which is 5 paisa or 5 cents, right? For 50,000 get requests, I'll be charged 2 cents, which you see how cheap it is. Okay, whereas if this increases, let's say I'll be performing, say, 1 lakh writes and 5 lakh reads, or 10 lakh reads. Let's assume 10 lakh reads. Okay, 1 lakh writes and 10 lakh reads. I'll be spending 50 cents and 40 cents. Apart from my storage is $12.5 for 500 GB. Okay, right, $12.5, right? Whereas for reads and writes, for writes, I will spend additional $0.5 US. For reads, I will spend additional $0.4 US, which all put together, it's going to be $13.9 US. Okay, so now this is the, you know, this is a massive scale infrastructure, storage infrastructure available for you at such a throwaway price, correct? So that is the cost benefit that AWS provides, right, with respect to S3, right? And this is a good way to calculate how many reads and how many writes and how many reads you will have on your S3 bucket. You can estimate it based on that. Okay, cool. So now let's get back here. I'm just going to delete this bucket, or I'm just going to keep it, or you can also empty the bucket completely. You can just select the bucket and empty it completely. Okay, and I'm going to just go, just going to say permissions. I'll remove block public access settings. I don't want anyone else to fiddle around with my bucket. I'll just say save changes. So once I save, I'll just give a confirm. It's confirmed. Okay, so now all public access is removed. Now you can just go ahead and refresh that. You won't be able to access the bucket. Everything will give access denied. Okay, so cool. So now what I want you to do today is assignment. Let's get to assignment. S3. I want you to read two documents today. One is our standard product documentation. The other one I want you to read is there's a nice blog. Okay, there's a nice blog, jayendrapatil.com. He writes very nice blogs on summarizing every service. So I've just given that link. Go through this blog, right? You will get snippets of key points summarized in one single page, right? You can just go through the first three sections, right? This section S3 buckets and objects, S3 bucket and object operations. Forget about pre-signed URLs. We'll come back to that later. But the first three sections, I want all of you to go through, capture those points, write it down, right? Read it and perform a lab exercise for today, right? Lab exercises: create an S3 bucket and upload object. Don't log in using your root credentials. Using your IAM credentials, log into AWS console and navigate the S3 console. Okay, once you are in S3 console, okay, create a bucket, click on create bucket. Give a unique name to it. My RPL bucket 9th November 2020, that's the name that I'm giving, and select the region as AP South 1, block all public. Okay, I'm just going to give us some screenshots of this. Okay. The third step is create the bucket. Once you create the bucket, click the bucket, go to objects and upload an object using upload button. Create a new text file, something hello world, can be anything, and upload it to the newly created bucket. Try accessing the new object using the URL. Using the objects URL, and just try accessing that using the objects URL. Unique URL. Insert pictures from file. Search. Yeah, using this URL. You should not be able to access it. Okay. Now, fifth step is make the S3 bucket public. Go to the bucket, go to permissions, and edit the permissions. Okay. Remove all public, block public access. By going to the bucket, permissions, uncheck block all public access, and save. And save by giving confirmation. So that it is saved. Yeah, that's done. Then you go back to objects, select the object, go back to the object, go back to the bucket, and select the object, and click on actions and make public. Click on actions, make public. Try accessing the object using, you should be able to access it. Okay. Eighth is try versioning by enabling versioning on the bucket. Okay, you can go to properties and bucket versioning. Enabling versioning on the bucket, clicking on properties, edit bucket versioning, and make it enabled. Save changes. Upload multiple versions of the same object and review their versions from the objects version tab. Okay, so let's do this. Let's do these topics today. And you don't have to worry too much about the bill because S3 is covered under free tier. I'll tell you how much is covered. Go to free tier. Yeah, and then review S3. Yeah, storage. If you see storage, Amazon S3, 5 GB is standard storage is free, and 20,000 GET request and 2,000 PUT request are free. So you can write 2,000 times, and you can read 20,000 times, and you can store up to 5 GB of. So all of our lab exercises will hardly exceed this. So you don't have to worry about it. Every month you are free for this much. Okay, all right. So I'm just going to share this document with all of you. So please go through this and get into your breakout rooms and please access your AWS accounts and start performing your lab exercises. Okay, I'm just going to give you the whiteboarding document as well, which is yeah. Okay. Okay, all right. So then let's take a pause here, right? Again, I'll see you all tomorrow, and you can go to your breakout rooms and start reading through the S3 and blogs on S3, and then perform the assignment for today.
Excuse me, sir.
Yeah.
Once we upload the new version, the previous version still take the volume space? Or there will be like...
Yeah, the previous version also takes the space. So every version is stored actually. Okay, but AWS efficiently manages that. I mean, they ensure that, if it is an incremental, wherever they can deduplicate the data, they will deduplicate the data at the storage level. But yes, you are right. It also stores the previous versions.
About you, Shavlo.
Okay.
So in our example, the total usage space will be 57 plus 38 plus 19, right?
Correct.
Yeah. Okay, sir. Thank you.
I'll come back to that maybe in our advanced session tomorrow. I'll have to introduce you to a few more concepts around how S3 stores the data, right? There are nice articles around that. I'll explain those to you. Okay. Okay, all right. So if there are no more questions, let's break here. Let's come back tomorrow for a more advanced S3. Tomorrow, I'm going to actually show you how you can use S3 to host your website, correct? And how you can use your S3 to build a quick HTML website and host your own website, a static website, not a dynamic page, a static HTML page. It's going to be quite interesting. Okay. Okay, all right. So thanks for attending today's session. So now please get into your breakout rooms and start practicing. Yeah, so over to you, brother Sai Krishna and mentors.
No, Sai Raman, thank you.